Good afternoon, everyone. It's a great privilege to welcome our distinguished speaker for today's session, Dr. Mohammad Anis V. Dr. Anis is currently serving as Director of Aeon's AI Technosis Solutions Private Limited, Cochin. As an expert in the field of artificial intelligence, computer vision, and large language models, he holds a PhD in computer science from FISAT with research focused on real-time surveillance, analytics, and abnormal behavior detection in high-density crowds. With over 8 plus research publications in reputed national and international venues and 13 plus impactful industry projects, Dr. Anis has made significant contributions to solving real-world problems using AI. His work spans areas such as pothole detection using deep neural networks for Mercedes-Benz car, intelligent document parsing using LLMs, face recognition systems, traffic analysis, and behavior modeling. He has extensive experts in cutting-edge technologies, including GPT, computer vision frameworks, and deep learning architectures, and has successfully led multiple AI innovations across industries. Dr. Mohammad Anis B is also a passionate academician and mentor, having delivered numerous invented talks and faculty development programs across prestigious institutions. His dedication to research, innovation, and knowledge sharing makes him a highly respected figure in the AI community. Today, he will be sharing his insights on LLM, workflows, and RAG pipeline, a topic that is shaping the future of intelligent system and generative AI. Let's extend a warm welcome to Dr. Mohammad Aniswi and look forward to an insightful and inspiring session. Over to you, sir.
Okay, thank you. Thank you for the introduction. Give me a second. Hope my screen is visible to you.
Yes, sir.
Okay. So we can start, right?
Yes, sir.
So today, actually, we are going to discuss the fundamentals of retrieval augmented generation and LLM workflows. Okay. So before going to the details of RAG, basically retrieval augmented generation and LLM workflows, we need to know why we require all these things. Okay, so we know we all are using LLMs, right? Maybe you are using GPT, Gemini, Claude, or any other LLM platforms. So what are the basic limitations of all these LLMs? And why we require actually these RAG and workflows, or why we require RAG and how we can implement workflows. So these are the things we are going to discuss in today's presentation. So the agenda of today's presentation is, first we will see what is LLM and what are their limitations, then why we require RAG to overcome those limitations. Then we will discuss the core architecture components of RAG. Then we will discuss how to implement the RAG applications, and I will show you some hands-on things also. And we will see some advanced RAG techniques, like how to optimize a RAG pipeline. Then we will see how the workflows can be implemented, the traditional workflows as well as the agentic workflows. And we will discuss some real world examples also. So I think the best way to start is to start with the large language model. Okay. So all of us are using large language models or generative AI extensively nowadays. So what is the suppose we are using Chat GPT. There is a mod. We know there is a model behind this Chat GPT and all these IDs, not IDs. This front end. Okay. So basically that model. So in behind the Chat GPT, we are using a model called GPT, right? So the current version is GPT 5.4. So so there is a wonderful architecture behind all these uh, generative AI models. So that model is basically known as transformer architecture. Okay. This transformer architecture is actually introduced in 2017 by Google in a paper called Attention is All You Need. So actually this transformer architecture is basically an encoder decoder architecture, and the most important feature of this transformer architecture is attention. You may know all these things, or you may have already discussed in the uh, previous sessions. Okay. So so attention is the most important component in a transformer architecture. Actually this attention makes this transformer architecture this much powerful. So when this transformer architecture is trained on huge amount of data, we have the LLMs, the large language models. So the large language models means the transformer architecture is trained on very huge amount of data, and it may contain lot of books, lot of resources, lot of websites, Wikipedia, and all such resources are actually trained on this transformer architecture. Then we will get a model called LLM or large language model. Okay. And what are the basic capabilities of this LLM? The basic capability of this LLM is basically the generation. That is why we called it as generative AI models. Okay. So, actually in 2021 or 22, the GPT 2.5 comes. When GPT 2.5 comes on the scene, we know actually the main advantage is we were not able to handle numerous problems before GPT. Actually, now we can handle, or we can create lot of automation. We can handle lot of industry problems using all these GPT and LLMs. So the basic capability of this LLM is basically the generation. Now, reasoning is another important feature, because when we ask something to GPT or Gemini, it can reason. It actually, the reasoning models are also available. Initially, we don't have the reasoning model, but currently we have the reasoning models also. Then lot of especially in industry, we are extensively using AI coding platforms. We have a lot of AI coding platforms like anti-gravity, cursor, warp. Lot of AI coding techniques we have. The most important one is the cloud code, and we can use these LLMs for different kind of tasks like translation, summarization, extraction. Lot of tasks can be automated using these LLMs. And as we know, the leading models are GPT, Claude, Llama, Gemini, Grok, Mistral, and many other models are available. Day by day, a lot of new models are actually introduced in the industry. So we can choose the model depends on our use case. And when we want to use GPT or Gemini, we need actually in the internet connection, right? Because the model is actually running on the server. Lot of open source models are also available. Llama is the most important one. Google has introduced Gemma, and Quen is there. Lot of open source models are also available. These models can be hosted in our local server, and we can use these models in our premise also. So how these LLMs can generate text or in be a text, image, or video, anything, because it is trained on a huge amount of data, and there must be a supervised fine tuning also. Okay, it is trained on huge amount of data. That is why it has this much amount of data. Okay, when we ask anything, we will get the answer, right? So that is the advantage when we are using the LLMs, right? But it has some limitations. So actually, these limitation leads to the significance of retrieval augmented generation, or RAG. So when actually, I think in 2022, the GPT 2.5 was released. Actually, that time, the FIFA World Cup was going on. When FIFA World Cup was going on and it was completed, and Argentina was the champions, right? So after a few days, when we ask who is the current champion of FIFA 2022, then we don't get an answer. Why? Because the knowledge cutoff of that GPT 2.5 model is actually 2019. That means up to the data up to 2019, the GPT 2.5 was trained. So there is a knowledge cutoff. It cannot access, actually an LLM model cannot access the real time data. So that is the basic, that is the fundamental limitation of each and every LLM model. If you ask the real world things or real world data, nowadays we will get it through the GPT, because it has actually integrated a lot of tools, lot of MCP servers. All these things are actually integrated with the LLM. That's why nowadays we are getting the answers. So the limitations of standard LLMs or standalone LLMs. I'm talking about the standalone LLMs, not the LLMs with the tools. Okay, because nowadays all the platforms, it may be maybe in Gemini, Claude, Grok, or GPT, they have a lot of tool callings. That is why they were able to access the real world data. They were able to access uh, the other resources. All those things can be done using tool calling. So when we talk about the standalone LLMs, that means LLM is basically a closed loop. So what is the basic functionality of LLM? If we ask anything, okay, if we ask anything, that means if we prompt, we will get the response. It doesn't have the thinking capacity. It doesn't have the access to any other external sources. Okay, so one of the important limitation is knowledge cutoff. That means in the GPT-4o is the one of the uh, most famous models released by GPT. So, but the training cutoff is 2023. So when we ask a data beyond 2023, it was not able to access. Suppose we are building a system, or suppose we want to build a system that can monitor the real time weather or real time stock updates. We need real time data, right? So in that case, we have to integrate those data sources to our LLM. Otherwise, it was not able to give the correct answer. And second limitation is hallucination. So what is hallucination? Hallucination means that is the biggest drawback actually. Sometimes LLMs will give you the wrong answers with very high confidence. They will give you blunders actually. They will give you blunders with very high confidence. So when we use these LLMs in a production scenario or in an industry scenario, we need to reduce the hallucination. The second thing is we need to access the external sources. Okay, then only we have to use all these things in production scenarios. Then no citations. No citations means if you ask anything, it will give you the response from the data they have trained. They don't know from where actually they are getting this data. They have a huge amount of data. From this huge amount of data, they are giving you some response. It may be right, it may be wrong. They don't know exactly whether it is right or wrong. And if you want to verify it, we don't have any citations or references. So that is the third one. And the domain blindness. Suppose if you want to implement this in a legal scenario, okay, they don't know, they may not aware about all the legal things. So in that case, we have to teach them the domain knowledge. We have to give them the domain knowledge. So suppose we want to build a system for colleges, a chatbot for colleges. In a the college has a lot of policies like leave policy, students policies, teacher policies, a lot of policies are there. And if you want to ask something about those policies, the GPT doesn't have that information. In that case, we have to integrate or we have to give those information to the LLM. And the fourth one is, of course, the token limit. Suppose we want to extract data from a huge PDF. It won't pass all these texts because there was a token limit. There was an input token limit as well as the output token limit. So how to handle this token limit? So when we build a system for an industry or academia or anything, we need to control the hallucination. We need to embed the real-time data. That means we need to avoid the knowledge cutoff. Citations should be there, and we have to give the domain knowledge, and we have to handle the token limit also. Okay, so to handle these 5 problems, we have a solution called RAG. Okay, so before going to the details of RAG, I will show you how how or what exactly happening when we are using an LLM with knowledge cutoff. Hope my screen is visible. Okay, so we are going to implement or we are going to showcase all the coding stuffs in LangChain. It is connecting. It will take some time. Okay, it is connected. So to implement this, we have to install LangChain, OpenAI, and LangChain community. And LangGraph is also required. So here we are using a model called GPT-4o. Its cutoff is actually 2023. And if you ask a question, who won the Nobel Prize in 2025? And we have given a system prompt like answer the following question question as accurately as possible. Okay. So when we ask this question, it will give you an answer I'm sorry, I cannot provide real-time data or future information. As of my last update in 2023, I don't have any information about the Nobel Prize winners in 2025. Okay. Actually, we are asking this question in 2026, right? So this model doesn't have the information about the Nobel Prize winners in 2025. How we can handle this? We will see how we can handle this. So to handle this LLM limitation, we have different methods actually. So the first one is prompt engineering. You know what is prompt engineering, right? So usually when we build a system using GPT or Gemini, we have to write the prompts. Okay. So when we are writing the prompts, there are some standard methods to write the prompts. If we ask lot of instruction in a single paragraph or a single prompt, it won't work effectively. So in that case, we have to standardize the prompt. To standardize the prompt, we have a lot of methods. So some standard methods are zero-shot learning is there, few one-shot learning is there, few shot learning is there, chain of thought prompting is there, tree of thought prompting is there. So a lot of standard techniques are there to prompt. So if you are very good at prompting, you can reduce these issues, or you can reduce the hallucination and all up to some extent. But the accuracy is limited, still it doesn't have any access to the external data. So when you're playing with the already available knowledge, the prompting will help you. So there is a new job role in the industry called prompt engineers. Not new, actually 1 or 2 years old job. And another method is, as you know, as in every AI solution or AI model, fine tuning is here also. So you can fine tune the model according to your convenience or with your data. But the data preparation time will be very huge, and the data preparation effort is also very huge, and the model fine tuning will require a huge infrastructure if you are using an open source model. Otherwise, if you want to fine tune the GPT, they will provide. They are providing the resources and all, no issues. But if you want to fine tune an open source model at your environment, it will cost you actually. And even but the fine tuning has also some limitations, because again the data will be limited. And another method is RAG, retrieval augmented generation. In retrieval augmented generation, we can plug the external data, we can plug any data source. We have a standard way to implement the thing, and we will get, or we are able to create the desired product according to our convenience. And recently we have agents and tools. The agentic, what is agentic AI and how to use those agentic AI in building the products, right? So here we are going to discuss how the RAG can be implemented. So why we are using RAG means, when we use RAG, the model actually no need to memorize all those things. When we are integrating the external data sources, and when the user is prompting, it can check with the external data source, it can fetch the answer from the external data source, and it can present to you. That is the advantage. No need to memorize anything. Just look at the data source, fetch the information, then present to you. That is these are the things actually a RAG application is doing. Okay. And the advantage is, when we are plugging an external data source, what are the contents of this external data source. So it is a verifiable information, and the hallucination is also very less. And you can integrate your fresh and private data. Suppose you want to build a chatbot that can talk with your database, your organization database. You know the database is always updating, right? Suppose as a principal or a manager, suppose you want to know who are on leaves today. So if you want to know who are on leaves today, you want to access the latest information. So you will get, if you integrate all these things, you will get, or you will always get the latest information. And from then the fourth one is source citations also there. From where actually this data is coming. And if you use LLM alone, you don't know from where this data is coming. So source citation is also there. So reasoning and verifiable knowledge, you will get the reasoning and verifiable knowledge, and you can reduce the hallucination, and you can integrate fresh and private data, and also the trustable one. That means the citations are also there. And when we talk about why RAG is more important than fine tuning, because one of the important thing is the cost. Okay, suppose if you want to fine tune something, of course the cost will be very high. And the second one is dynamic knowledge. Always you will get the latest data, but when the fine tuning, if you fine tune your LLM model with your database, it won't get the latest data. Okay, if you fine tune today, it won't get the information, it won't get tomorrow's information, right? But when we have the RAG, it always get the latest and updated information. And the second one is cost effective. In a very low cost, we can integrate or we can implement RAG. And using the standard methods, we can reduce the hallucination. And for many use cases, almost 90% of use cases, you can proceed with RAG. If the RAG is failing, after experimenting all these standard methods, then only you need to proceed with the fine tuning. Okay, so when we are building a system, don't go with fine tuning initially. Just check RAG, try experiment all the standard methods. Then in most of the cases, in 95% cases, you will get the desired answer or the desired behavior. But if you don't get answer, and if you don't want to access the real-time data and all, then you just proceed with the fine tuning. So before going to the details of RAG, I will show you how the same query works with the RAG. We have already seen a query who won the Nobel Prize in Physics 2025. At the time we got the answer, the system don't know, right? So now I will try to integrate an external source. Okay, that means the web search. So the external, here you can see a package called DuckDuckGo. So DuckDuckGo is actually used for web search. So how the behavior changes when LLM with a web search tool? Let's see. So we have created an agent with DuckDuck search tool, and I am asking the same question. Okay. So we are getting the answer, right? The 2025 Nobel Prize in Physics was awarded. Okay, for their work, quantum mechanical phenomena. So this is the difference. So when we ask the question to LLM, you won't get the answer. But when we have integrated a data source, here I have integrated the web search tool. At that time, you are getting the answer. Nowadays, when you ask these things to a GPT, you will get, because they have already integrated these tools with the LLM. But when we are building an enterprise system, you are going to use the LLM APIs directly. So when you are using LLM APIs directly, you won't get the tools. So you have to integrate the tools. You have to create the tools. You have to integrate the tools. So what we will see, what is RAG, or what is retrieval augmented generation. So RAG actually help us to enhance the retrieval efficiency. Okay, retrieval efficiencies. That means it help us to retrieve information from any external data source or external knowledge base that is integrated with our system. So the architecture is like this. When the user is asking something to the LLM, before feeding this query directly to the LLM, the system will convert this query to an embedding. Okay, so we have a lot of embedding models available. So embedding means we are just converting it as a vector representation, okay, or number representation. Then we have a knowledge base. We already have a knowledge base. So what usually we have done, all these knowledge base are already embedded and stored in a database called vector database. Okay, so in RAG we are using a specialized database called vector database. So if you have a data source, suppose we want to access something from a PDF. Okay, so what we have done, we have converted the entire PDF and stored in a database called vector database in an embedded format. That means in a number representation form. So when the user asks anything, the user query will be converted to embeddings, and these embeddings will be matched with the already stored embeddings using cosine similarity or any other similarity measures. Okay, then it will fetch the required chunks, or the matching chunks from the vector database. Then we will give all these things to the LLM. LLM will analyze the chunks we have retrieved and the user queries, and finally you will get the response. Okay, so in this way actually the RAG is working. So I will tell you once again. Suppose we have a PDF. From this PDF we want to extract the information. So what is the first thing we will do? We will convert this PDF into in a vector format using any embedding techniques that is already available. So once we have converted this into an embedding format, it will be in a number or vector representation that is stored in vector database. So now in our vector database, we have the embedding of the PDF. Okay, actually in this PDF we are going to query, right? When user asks something, it will convert the user query into the embedding using the same embedding techniques that we have used for embedding the document. Okay, then the user embedding and the embeddings that is stored in the vector database will be compared using cosine similarity, and we will fetch, or we will take n number of chunks. Okay, n number of chunks from the vector database, and we will give all these things to an LLM. Then LLM will analyze all these things and will give you the desired output. In that way, actually, the retrieval augmented generation will work. So the fundamental RAG architecture or Naive RAG architecture will be like this. You will have a document loader. So initially we have discussed one limitation called token limit, right? So you know what is token, right? A token means a for length word. So at a time, an LLM can accept a fixed number of tokens only. Suppose you want to process a 1,000-page document. In that case, LLM won't accept it in a single pass. So what you have to do? You need to split the document, right? So once you have loaded the document, then you have to split the document. So this splitting is actually known as chunking. Okay. So once we have n number of chunks, we will embed all these chunks separately. Okay. We will embed all these chunks separately and we will store it in the vector database. Okay. And we have a component called retriever. Actually, this retriever accepts the user query, then convert into embedding, then matches with the vector database, and finally the LLM will give you the response. So this is the architecture. So in the architecture, we have document loader, text splitter or text chunker, embedding model is there, vector database is there, retriever must be there, and finally, the most importantly, we have the large language model also. But when we are chunking, some issues are there when we use it in practical scenarios. Sometimes when we chunk manually or fixed size chunking, the continuity will be lost. So when the continuity will be lost, you won't get the desired answer actually. So this continuity should be maintained using some standard techniques like use the small chunks, then overlapping chunks should be there. So using such standard methods, you can control this. And if the chunks are not good, it will affect the retrieval quality also. And of course, another thing is the context window pressure. Okay, we have to limit the chunks inside the context window. Actually, when you design a system, just think that you need to pass n number of chunks with your user query as well as system prompt to the LLM. Okay, suppose the input context limit size is 1,000. Okay, and if you retrieve 3 chunks, okay, your chunk size is 300. Suppose your chunk size is 300, and if you retrieve 3 chunks, the total size will be 900, right? 900. And suppose your user query contains a 70 tokens. Okay, then the total will be 970. Suppose we have a system prompt with 100 tokens. So the total token size will be 1070. So the LLM cannot process it. So make sure that the retrieval chunks plus user query or user prompt plus the data and everything will be under the token size. And another thing is, I have already mentioned that many chunks contain same information. Suppose in the document itself, a data may be available in multiple pages. And we have some overlapping chunks also. Maybe this overlap chunk contain a crucial information. It comes in 2 chunks, right? It comes in two chunks. So when we are trying to retrieve this, we need to process these 2 chunks. So and when the LLM looks at this, LLM can identify that, okay, two information about the same query is there. So we have to deduplicate this. So dedupe the redundant information is one of the important challenge. And the LLM cannot reasoning. LLM actually some reasoning models are there, but traditionally LLM LLM doesn't have the reasoning capability. So the RAG, when we talk in detail about the RAG components, we have two things. One is two parts actually. One is data ingestion part, and second one is retrieval and generation part. So when we talk about that, the data ingestion part, the main components are the document loaders that we have already discussed, then chunking strategies or splitting. Okay, that is the second component. And embedding models. A lot of embedding models are available. OpenAI is giving you the embeddings with very low cost. Gemini is also giving you. Then vector database. So vector database can be selected according to your convenience. Chroma, Quadrant, all those things are the most widely used vector databases. I will see you the coding example later. And at the retrieval and generation side, we have the query embedding. Then using the cosine similarity, we need to search the database. Then if you have a ranking mechanism, we need to rank the chunks. Then we will construct the prompt using all these things. And finally, the LLM will generate you the answer. Okay, so in this way, actually, the RAG is working. So I will show you how to implement RAG. I'm just uploading a HR policy document that is just downloaded from a random website. So first we need to install the required dependencies. So LangChain is the framework we are using. So we need to install LangChain OpenAI, then LangChain community package is there. And to pass the PDF, we need to use PyPDF. FISAT is there. FISAT is the vector database that we are going to use. And we are going to set the LLM as well as the embedding. Here we are going to use GPT-4o, that is the LLM model we are going to use. And we are going to use OpenAI embedding, that is text embedding 3 small. Okay. And of course, you need an API key if you want to use the closed models. Okay, you can see the message LLM and embedding models are initialized. Now the first step, the first step is the document loader. Okay, so we need to load the PDF. So using this PyPDF loader, we are loading the PDF and we are just printing the content on the first page. The first page up to 60 characters, we are just printing. The document contains actually 70 to 80 pages, I think. So the employee handbook PDF loaded successfully. So we have the total pages, 79 pages, and we are printing sample from page 1. you can just read it. And what is the second step? The second step is chunking, right? We need to split this document into n number of chunks. So here we are using a recursive character text splitter. That is the inbuilt, that is one of the inbuilt chunking techniques that is available in LangChain, and we are going to use chunk size with 600 and chunk overlap is 100. Okay, and using the text splitter dot split documents, we can split the documents into n number of chunks, and finally we will print the number of chunks also. So you can see that we have created or 332 chunks. Okay, and just previewing from the chunk one. So this is the first chunk. So once we have done chunking, what we need to do, we need to create the embedding of all these chunks, and we need to store it in the vector database. Okay, third and fourth step. So FISAT is the vector database we are going to use, and embedding is we have already defined what is the embedding we are going to use. That is text embedding 3 small. Okay, so document is means chunks that we have already created. We have in these chunks we have 332 chunks, and that using OpenAI embedding we will create this and we will store it in this vector database. Okay, so now it is creating, or it is okay, it is creating the embeddings and it is storing it. So vector store created successfully. So that is the data ingestion part. And in RAG component, we need to query, right? So for that, we are creating a chain. So first component is, of course, the query embedding, then similarity search, then prompt construction, and of course, the LLM generation. So for the retriever, we are just defining a retriever function, and we are creating a prompt. Okay, you are a helpful HR assistant. Answer the question based only on the employee handbook. Okay, and the context is also given. Then I have given an instruction like answer professionally and clearly. Okay, and in the RAG chain, I have given the context, then question, that is the RAG prompt, and also we need to use the final one, that is the LLM. Okay, so once we have run this, our simple RAG chain is ready. And I have a couple of questions with me. So that as questions, what is the leave policy in the company? How many casual leaves can employee take? So such questions are there. So when we run it, you will get the response one by one. You can just see this. So in this way, you can build a RAG system. Okay, hope you are clear with the RAG system. So this is the simple or basic RAG architecture. Okay, and when we are building an industry standard system, if you follow this basic architecture, you won't get the required or desired performance. So we will see how to improve all these things. We will see in the coming slides. So this coding example that I have already shown to you. And when you are getting a response from the LLM, how you can evaluate all these things, that is most important, right? So when LLMs are on the scene in the industry, the main issue we have faced is it is with the testers. Okay, because they are familiar with they are familiar with testing the traditional website, the traditional workflows, then the AI system, basically like computer vision, NLP. In all those things, we will get, we will always get the desired output, right? Or we have a deterministic behavior while testing. But when we have started implementing the solutions using LLMs, they actually don't know how to test all these things, how to state the accuracy of this retrieval. So that is most important actually. So you need to check the context relevance. Okay. So just measure how relevant the retrieve information that is related to user query. Okay, that is one thing. And another one is faithfulness. Basically, it won't take the response from any other data. Stick with the data that you have provided. That also you need to check. And of course, the answer relevance. How the answers are relevant to you. So these things actually you need to check. So to check this, you have a lot of platforms. Dagas is one platform. Lagsmith is another platform. TrueLens is an open source one, and most widely used. Actually, we have used in our industry is Phoenix. Phoenix is very easy to implement. You will get all the telemetry in Phoenix. Okay. Now we will see how to improve the accuracy when we are building a RAG solution. So we have three methods basically. One is hybrid search, second one is re-ranking, and third one is query rewriting. So when we talk about the simple RAG application or architecture, only the vector search or semantic search is happening. But if we integrate both the lexical and semantic search to capture the behavior, then it will work better than the simple RAG architecture. And second one is basically re-ranking. Then, so when we are getting n number of chunks with the priorities, just check the priority with another LLM model. Okay, so that can be done, and it will of course improve the accuracy. And the most important one is query rewriting. So when the user asks something in his language, actually, language means not English, Malayalam like that. He may use broken things, right? Broken language. So in that case, the LLM sometimes won't understand this broken language. So in that case, if you are able to rewrite the query in a standard way, and if you pass this rewritten query to the LLM, it will of course work better than the previous. So these are some standard methods. And another important thing is metadata filtering. So instead of taking only the relevant chunks, we are also filtering the metadata that is also stored with the data in the vector database. Okay. Other than the content, we are also storing the metadata also. So when we are retrieving, if you filter with metadata also, then of course it will work better. Hybrid search, I have already discussed. Then in query transformation, we have different methods actually. The first one is multi-query retrieval. The second one is step back prompting. Third one is hypothetical document embedding. and finally rewrite, retrieve, and read. Okay. Actually, in multi-query retrieval, when user asks something, the LLM itself rewrite the query into multiple subqueries. Then run them all the queries, then finally combine the results, and it will give you the appropriate response. And in step back prompting, suppose the user asks a specific one, the system itself wider the range, okay, or the border will be enhanced. Instead of just checking the precise one, just enhance the border, then retrieve the chunks, and from those enhanced chunks, it will find the results. Then hypothetical document embedding, actually the LLM generates a hypothetical answer. Then these answers or the embeddings will be used for the matching with the vector data that is stored in the vector database. And rewrite, retrieve, read means it is basically an iterative process. So the user actually, or the LLM rewrites the query based on the initial retrieval results. Okay. So if it retrieve chunk 1, the the LLM will check the query with the chunk 1, then rewrite it. So once we have chunk 2, the LLM again rewrite it. If once we have the chunk 3, it again rewrite it. So iteratively, it will rewrite the prompt and fetch the information from the vector database. Okay. So I will show you how all these things go. So before that, I will just discuss re-ranking also. So in the re-ranking, initially we will have the document, and we will have some specialized model to check the retrieved things. Okay. And we will re-rank the entire things, and finally from the re-ranked chunks, the LLM is extracting the information. So it will help us to improve the accuracy. So I will show you how this hybrid search and the query transformation will work. I have used the same PDF, the HR policy. So that is the desired packages are installed. Just setting up the LLM model as well as the embedding model. So we are doing the chunking process. Here I have used 700 as the chunk size, and overlap is 100, same as the previous case. The previous step was not completed yet. Okay, so setup is completed. Now the chunking is going on. So the PDF is loaded, created to 88 chunks with metadata. So what is metadata? The metadata contains the page number, then HR policy, and the section also. Okay. Then we are storing this content as well as metadata in a vector database. You can see the document, the page content, as well as metadata in a vector store. So first, we will see how the hybrid search and metadata filtering works. So I am asking a question. What is the leave policy here? Okay. What is the leave policy? So first I will try with simple vector search, then metadata filtering, and the combined one with the metadata. Okay. So in the semantic search, we got the result in page 52, the leave policy, the objective. Okay. And in the result page 5, we have the leave. In the result page 5, we have the maternity leave, etc. But in metadata filtering, we got results from page 39. This is a little more accurate, but the question is different, I think. Yeah, it was about the probation period. Okay, it was about the probation period, but the more specific answer, and using the metadata filter, we are actually filtering it. And the third one, search with metadata filter. So when we search using metadata filter, the results will be little more accurate. Okay, don't confuse with the results because I haven't implemented the full pipeline, just filtering also. Okay, filtering only. So these are the retrieved chunks. Okay, and finally we will see how the results comes. Okay. So I'm using the metadata with the search with metadata filter for the retrieval. Just what is the probation period of the employee? Answer: the probation period of new employee is 6 months. That means you are getting the accurate results, right? You are not getting any junk result or any unwanted things. The second question was, tell me about the leave policy. You are getting about earned leave, casual leave, etc. So you are getting all the required information. Okay. So in that way, you can improve the accuracy. Then another thing we have discussed is query transformation. The notebook is connecting. Installing the packages, the same HR policy, the PDF loader, text splitter, then vector store, everything has done in a single cell. Okay. So it is loaded. So the first one is multi-query retrieval. So in multi-query retrieval, we are using an LLM. You just read the prompt. You are an expert HR assistant. Generate 3 different versions of the following questions to retrieve better results from the employee handbook. So each version should look at the question from a slightly different angle. So what they will do, it will create 3 versions of the questions, retrieve the chunks, then combine it, deduplicate it, and finally you will get the answer. Okay. So if you run it, so the original question is, what is the process of taking casual leave? So we have created 3 subqueries. What steps should employee follow request to casual leave according to employee handbook? Are you the specific guidelines? Are these specific guidelines or requirements outlined the employee handbook for applying the casual leave? And can you explain the procedure for submitting casual leaves? So we are getting 3 different angles, and most importantly, standard way of questioning or standard way of prompting, right? So these prompts will hit the database or vector database in a 3 different way, and we will get the responses, and we will combine the results, and it will present to you. Then second one is back prompting, step back prompting. In the step back prompting, you are just see actually the difference is in prompting. Actually, given the specific question, first create more general and conceptual questions that would help to retrieve broader and more relevant information from the handbook. If the question is very narrow or specific, it will create broader view. Okay. So here, original query is how many casual leaves can employee take in their first year? Step back query is what are the leave policies for the employee, including types of leaves, accurate rates as outlined the employee handbook. So more general one. So if you ask more general thing, it will fetch all the required information. Then the LLM can handle it. And next one is hypothetical document embedding. Write a detailed hypothetical passage as if it came from employee handbook that would answer the following question. So it will create a hypothetical answer. Then it will give you for the embedding. So here the question is, what is the probation period for and confirmation process for at Great Lakes? Great Lakes is the employee handbook I have downloaded. So it is a hypothetical document generated. Then compare it with the already stored embeddings that we have. Then simple rewrite, retrieve, and read. So in that way, iteratively we are improving the prompt. So just check how it is working. We have a query. Actually, that coding is actually missing. This is not the one actually required. Okay. Anyway, it will continuously improve the accuracy. Sorry, and improve the query. Okay, in this using these four methods, actually you can improve the quality of prompting. Okay, the quality of the questions you are asking. So that this is very important when we are dealing with a RAG application. And some more methods are there actually. So the parent document and hierarchical retrieval is there. Suppose you want to get an information from a small chunk, just identify its parent document and or broader things and retrieve from this broader domain. Okay, and semantic chunking that we have already discussed. Then graph rag is also there. Instead of storing the metadata and all, it will organize in the graph rank. It will organize the information in a graph format. That means the entities, relationship between the chunks, all those things will be stored in a graph knowledge base. Okay, so when we ask questions, it will actually suppose it will fetch information from one chunk, then there will be another chunk that is related to that or that is connected to this chunk. So in a graph format. So that is also retrieved. So the connected things are retrieved, and finally you will get the answer from these connected components. So that is actually the graph rank. Then recently we have self-rag and corrective rag. So self-rag means the LLM itself will evaluate the answer. Okay, LLM will itself evaluate the responses and identify the potential inaccuracies, and then finally it will improve itself. Okay, it is like self-critique. Then confidence-based or confidence-based adoption is there, because when LLM produce an information or an output, it has a confidence measures also. Okay, if the confidence is very low, same as in all deep learning or other LLM model, LLM also has the confidence score. So when the confidence score is very low, it will search again. Okay, it will search again, or it will use some other methods to enhance the accuracy of the retrieval. So that's all about the RAG thing. And we have actually one more things to discuss, that is how the LLMs can be used in a workflow. Okay. So before LLM, we have traditional workflows. The workflows means if it is able to do some specific task, okay, or if it is able to complete some specific task or automated task, then we can call it as a workflow, right? Give me a second. So here LLM workflow means we are creating a workflow system that connects LLM with the external tools, data retrieval, then decision making, and sometimes we are creating agents also. Okay, agentic based workflows are also there. So this LLM based workflows are actually helping us to automate the things. Okay, in RAG application, actually if we have a data source, and if we want to query something, we will get the answer, right? But if you want to automate anything, we need to use workflow. So to create a workflow, you need to organize the LLM and the corresponding tools. Okay, tools in a very structured manner. Okay, so the orchestration is the most important part when we are creating LLM workflows. And you can create any kind of workflows. It may be linear. Linear means only one flow will be there. Branching should be there. Suppose you want to integrate two kind of flows in a single system. Of course, you need to create a decision making or decision points. Then cyclic will be there. So lot of flexibilities are there. You can create the workflows types according to your convenience, your need. And it actually don't work on isolated prompts. It actually works with multi-step reasoning integrated with real-time data. And it has, if you are going with agentic thing, it can plan, it can execute the things. So in that way, actually, the LLM workflows can be created. So we will see some basic LLM workflows. One is summarization. Summarization means, suppose if you want to summarize a content, okay? So, if you want to summarize a large document into a summary, you can just create it using a workflow theme. Then classification and routing can be done. LLM can classify the required information, and it can route to a different extraction mechanisms. Suppose we are creating a workflow system that can extract information from different OVDs. That means original valid documents like Aadhaar or PAN. Okay. So in that case, the first thing will be the input, right? That is, the image will be there. The Aadhaar card or PAN card image will be there. So in the first step, it need to identify that the coming document is whether the Aadhaar or PAN. Okay. And if it classify it as an Aadhaar, it has a specific workflow or the flow to extract information from Aadhaar, right? Because the entities are entirely different. And if it is a PAN, we have another flow. So that decision should be made at the classification point. When classify accurately, it will route the system to the desired flow. Okay. So if it is an Aadhaar, it will go to Aadhaar flow. If it is a PAN, it will go to the PAN, just like as our if-else. Then chain of thought prompting is there. Suppose it will be like if how you are solving complex math problems. You will solve it by step, right? You won't do it in a single step. Suppose we are building a system uh, that is for a very complex task. In that case, we will split the large prompt into, or the complex task into simple simple task, and we will execute these simple tasks step by step. Okay. First we will fetch the information, then we will process it. In that way, we will do it step by step. That is basically chain of thought. And in chain of thought, the output of the first step will be the input of the second step in most of the cases, not mandatory. Okay, and we have a lot of frameworks like LangChain, Llama Index, Haystack, AutoGen, Crue. Lot of frameworks are there in LangChain. To generate LLM workflows. So we will see how a summarization workflow is working. It is connected. We are uploading the same HR policy document. Installing the packages, LLM initialization, then loading. So we will wait up to here. Okay. Okay. So the document is uploaded and splitted into 225 chunks. So we are just summarize the following text from the employee handbook in a clear, concise manner. Include key points only. Okay. And we are creating a summarizing chain. So using this pipe, you can create the chunk. A chain. So summarizing prompt, then LLM, and we have the standard output parser. So we have two methods. One is stuff approach. It will help you to summarize a small document. Okay. So that's why here we are taking only few things. So this is the summary. We are taking only the page one. Okay. And map produces the our interested area. Combine the following chunk summaries into one coherent, well-organized summary of the employee handbook. Make it structured and easy to read. Okay. Then reduce prompt, then LLM and standard out. Okay. And you will see how it is. We are taking only 8 chunks. We have 225 chunks. Due to the time limit, we are taking only 8 chunks here. So we got the summary, right? We got the summary. And if you want, you can refine the summary again. So you will get the final refined summary. Okay. Nowadays, all these workflows are actually replaced with agentic workflows. Okay. So in agentic, 4 components are there. One is planning. So if we give him or if you give the system a task, it will plan, it will execute, and it will refine also. So planning is the most important stage or component. Then memory is there. In memory, we have long-term and short-term memory. Long-term, short-term memory means it will be in the current life cycle, and then it will be a short-term one. If it stores all, the entire information throughout uh, throughout all flows, then we can call it as a long-term memory. Okay. Then tool calling. Suppose if you want to automate something, you need to call lot of external tools. Okay. So tool calling is the another important one. And finally, reflection, or we can say that reflection agent, because it will verify its own output, and according to the output, it will improve itself. Okay. So planning, memory, tool calling, and reflection are the four components or unavoidable components in agentic workflows. Actually, these agentic workflows are following a pattern called React. React means reason, then act. Okay. That is the foundational thing of each and every agentic workflows. So the first one is in React pattern. The first one is thought. So the LLM reason, actually we are using a thinking capability. So LLM will think about the situation or think about the task, then assess the goal, create the plan for the next step, and it will execute. And action means basically tool calling. So for each step to execute or complete the step, it may require an action. Okay, it may or may not be a tool calling. So if it is a tool calling, it will tool the appropriate call, fetch the information from the external thing, and it will give it. And the observation that I have already mentioned, it is done by the reflection agent. It will observe its own output and find and providing new information for the action. And this cycle will repeat. This is actually a cycle. This cycle will repeat until you get the final answer. So thought will be there, action is there, observation is there. Also repeat until you get the final answer. So a lot of orchestrations are there. Graph-based orchestration is there. Node-based, or node means node and edges are there. Then states are the. If you want, you can use states also. Actually, states are used to store the entire flow information. Okay, where actually the current flow is there. Okay, to store such information, we need to use states. So it is basically a graph-based one. It contains nodes as nodes. Then for the flow, it contains edges, and it has each nodes has a state. Okay. So in agentic RAG system or agentic flow system, actually the agent will decide whether it should answer directly or retrieve information from external source or refine it. All these things are actually handled by the agent. And this when we are talking about the traditional RAG, this dynamic behavior is not there. When it becomes a dynamic behavior, the agentic RAG or agentic workflow become most robust and adaptive than the traditional static RAG pipelines. Okay. So when it becomes dynamic, it will help us to improve the accuracy and flexibility. So when we talk about agentic AI system, it contains multiple agents. So we cannot create a system with a single agent in normal cases. So it has a lot of multiple agents. So one of the important agent that you need to use in your agentic AI framework is the supervisor agent. So there should be a supervisor agent. He will handle the entire things, the entire workflow, the state matters. All these things are handled by the supervisor agent. And you should have a planner agent also. So in this planner agent, uh, it when a task comes, this planner agent will create the plan for you. Okay. Either you can write, you can combine the supervisor agent and planner agent in a single agent, or you can take it as, or you can do it as a separate two agents. No issues. So once you have the planner, or once you have the plan, okay, when the planner agent creates the plan for you, there should be a reflector agent. This reflector agent actually review the plan that is created by the planner agent. Then, according to the plan, you have the execution agents. Okay. So suppose you want to take an information from the web. You have a web search agent. It will fetch the information from the web and will give you. And in that way, you have, according to the plan created, you will execute step by step. Okay. Each agent will create their own task, and finally you will get the desired answer. So we will talk about one simple use case, but that is chatbot, AI chatbot. Okay, the most familiar use case for you in recent days. Suppose you want to create an intelligent chatbot. Suppose I will say an example. Suppose you want to create a customer support chatbot that is for reviewing your payment. Okay, suppose you have paid something, but it is not reflected. Okay, so in that case, when you get the chatbot, usually first you will say hi, right? So when hi comes to the system, there should be an agent. It is not exactly agent. There should be a thing called guardrails. Okay, so this guardrails will detect it as a greeting message. So when the greeting message comes, the guardrail itself can handle it from guardrail itself. So the guardrail will, it is also an agent. So the guardrail will reply from, the guardrail will reply for the incoming message hi. Okay. Suppose your next question will be like, I want to know about the, I want to know the status of my payment. So in that case, the system will understand, okay, you want to know the status. That is your intention. Okay. So when the intention is clear, the guardrail will pass this query to the supervisor. Okay, supervisor also check this, then plan has created. Okay, so to check the status, you need account information, then you need the payment date or something, the account number or phone number or any data you want. So list the data you required. Then to check the status, you need to call this API. And finally, you need to give this response. So that will be the plan. So to get those information, you will have another agent. This agent will ask you, okay, what are these details? Once you have these details, then the system will have another agent to call the API, the bank API. Then it will check with the bank API and it will give you the status, and the status will be returned again to the supervisor agent. Then finally, there will be a reply agent. This reply agent will compose the reply for you and it will present you, okay, this is the status. In that way, actually, you can create a chatbot. It is not an Himalayan task. you can easily implement a chatbot using LangGraph, because most of the things are already predefined in LangGraph. So it is very easy. Just create the nodes, connect with the edges, then execute. Another one is you can the code based assistant and dev agent. Most of you are currently using this, right? AI coding techniques and all. So, but here I am talking about how you can connect your agent with your Git. Okay, I will show you an example. So here, I am not sure whether you can see this. So here I am using some Anthropic one. So I have a repo, local Git repo, desktop delivery projects, integrated data analytics. I will show you that one also. Okay, this is the project I have. And here I am using a Git MCP server to talk with my Git repo. Okay. So the MCP tools, so it will list the tools available. So based on the tools, it will execute. So my prompt is actually check status of repository and show me the difference of any modified files. Okay. So the Cloud Sonnet is using. So we will see how these things is working. Okay. So if you just see the output, you can see that connecting to MCP server, agent is processing check status of the repository. Agent is calling a tool, that is Git status, that is the tool. Then result from the Git server, repository status on branch S3 integration, nothing to commit. It is clean, right? Suppose I have made a small change in my Git repo. I'm just removing this, okay, and adding the key. And if I run it again, yeah, you can see that on the branches, your branch is ahead by 2 commits, because I have done some changes, right? The modified file is usergate.mt. Okay. Suppose I want to push this automatically in my repo. What are the things I can do? I can automate that one also. So for that, I have another code called auto commit. The same things. So instead of status call, instead of status tool, my prompt is please check the status of the repository. If there are modified files, stage them all and commit them with the message demo commit for MCP agent. Finally, report the new status. So I have to call two tools. One is need to commit all these things, then give you the status. So basically, if you use git directly, you need to use git status, git commit, and git status, right? So instead, I am automating it just. So if I run the file, yeah, you can see that connecting agent is processing tool output repository status. Yeah, branches ahead, changes that not stage for committees. Yeah, not stage for committees usergate.md. No changes added to commit. So first it will call git add. Okay, git add, then stage successfully. Then agent call git commit, committed successfully. Then status, your branches had 3 commits, and if you want, I can push it. So it will consolidate the things, initial status, check the repo, found user get modified. So stage the file, committed it, and final status, everything is clean. Okay. So you are getting, or you can automate these kind of things using agentic workflows. So when we create a system using agentic RAG or agentic workflows, the key challenges are make sure that you are getting high quality information. You are getting or you are retrieving very high quality information. And another thing is, if we use closed models or the cloud models, the latency will be there. And if you use open source model, latency will be there if you don't have enough spec. So this latency should be optimized. So this latency can be optimized using one is config, means one is system config, and another one is you can reduce the content that has been sent to the LLM. So reduce the content maximum, because it saves the cost also, because they are billing for tokens. So the cost must be minimal, and you need to evaluate the system continuously, because we don't get 100% perfect things using LLMs. Maximum you will get 99% accuracy. So you need to evaluate it continuously. And the security privacy concerns are there. If you are building a system for banking, healthcare, or any other data critical firms, they don't allow you to send data to the cloud models, because we don't know what GPT is doing with our data or Gemini is doing with our data. So in that case, you need to host an LLM locally. So you have to use Olama or any similar frameworks, but it is very costly, especially if you want to handle concurrent requests. The system spec cost will be huge. Huge means very, very huge. And if you, and some best practices are there. One is follow the standard prompting methods. Hybrid search and re-ranking can be applied, and data chunking can be avoided actually, because if you nowadays 128K tokens are supported with most of the LLMs. So if your data really goes beyond 128K tokens, then only you can go with chunking. Otherwise, but if you want to reduce the cost, of course, chunking would be better, because otherwise, if you don't do chunking, the issue is that the entire 128K chunks will go with one API request. Instead, if you can do it with 1,000 chunks, you can reduce the cost up to 1%, right? So that is the difference. So chunking is important, but optimized chunking strategy according to your need is should be implemented. And telemetry should be there. I am suggesting Phoenix because it is very easy to use. And guardrails, you have to use guardrails, because guardrails can handle greeting messages, prompt attack, prompt injection, out of code, uh, out of context queries. All these things can be handled using guardrails. So one of the widely used guardrail framework is NEMO guardrails, NEMO guardrails by NVIDIA. And of course, established continuous evaluation frameworks. You need to evaluate it continuously. And of course, the future trends, the AI adaptive and agentic RAG system, agentic workflow system, multimodal RAG system, graph vector hybrid structured knowledge. And another thing is, instead of using LLMs, if you can do your work with SLMs, small language models, proceed with SLMs, because the parameter size is very low, right? So that can also be done. So I think I have discussed, I have enough things, the how LLM works, what is RAG, how RAG works, different RAG approaches, then workflows, and also the agentic AI workflows. So I think I can stop here. And if you have any further questions, I'm happy to answer.
Any queries?
I hope there are no queries. Any queries? Good evening, everyone. As we come to the end of this meaningful session, I would like to take a moment to express our heartfelt gratitude to all those who have made this program a great success. First and foremost, I extend my sincere thanks to our esteemed speaker, Dr. Mohammad Aniswi, for sharing his valuable knowledge and expertise with us. Your session on LLM workflows and RAG pipeline was truly enlightening and has given us deeper insights into the evolving world of generative AI. I would also like to thank all the participants for their active involvement and keen interest, which made this session even more engaging. Once again, thank you all for your presence and support. Have a great day. Thank you, sir.
Thank you. So can I leave?
Yes, sir.
Yes, sir. Yes, sir. Thank you.